E1 and E2 elimination reaction and mechanism. Firstly, let me teach you some basic concepts. Let's consider alkene like ethene. We add HCl to it. We know that after reaction, we get alkyl halide. This reaction is called addition reaction because two reactants get together to form a single product. Or with the help of addition reaction, we convert unsaturated hydrocarbon to saturated compound. Now consider the opposite case. I take alkyl halide. I add some suitable reagent to it like weak base. After reaction, I get alkene like ethene plus HCl. We call this reaction as elimination reaction because this compound eliminate or remove two substituents like hydrogen and chlorine. Or we say that with the help of elimination reaction, we convert saturated compounds to unsaturated compounds. Hence, elimination reaction is the opposite of addition reaction. Therefore, we define elimination reaction as a type of organic reaction in which two substituents are removed from a molecule in one or two steps is called elimination reaction. Let me repeat it. A type of organic reaction in which two substituents are removed from a molecule in one or two steps is called elimination reaction. Remember that there are two types of elimination reactions. Elimination of unimolecular reaction, we call it E1 elimination reaction, and elimination of bimolecular reaction, we call it E2 reaction. Here, let me ask you one important question. What is the purpose of elimination reaction, or why we study elimination reaction? Well, the answer is simple. To convert saturated compounds to unsaturated compounds, our elimination reactions help us to prepare alkenes. Now here is another very important question which you must learn. Are elimination reactions endothermic or exothermic? The answer is endothermic. They need energy in order to break chemical bond. For example, elimination reaction occur above 50 degrees centigrade. Therefore, we say that elimination reaction favor high temperature. Let me repeat it. Elimination reactions favor high temperature. Hence, note down all these important points. Now we will study E1 elimination reaction and its mechanism. The first point is that they occur at high temperature above 50 degrees centigrade in the presence of weak base. Now we will learn the basic concepts. Consider this general alkyl halide. We know that this is alpha carbon and this is beta carbon. Now listen carefully. In the first step, alpha carbon loses this halogen X. The alpha carbon loses halogen X, hence positive charge appears on this alpha carbon. We know that this is carbocation. Thus we say that in the first step, carbocation is formed. Secondly, a nucleophile will attack on this beta hydrogen. As a result, it loses hydrogen and we get unsaturated compound. Thus we say that in the second step, nucleophile attack on the beta hydrogen. We learn that E1 is a two-step reaction. Secondly, we learn that beta hydrogen is must for elimination reaction. Without beta hydrogen, no elimination reaction can occur. Hence note down these basic concepts. In E1 elimination reaction, we take tertiary alkyl halide. We also call this alkyl halide as 3-degree alkyl halide. We add weak base like methanol. Now this halogen being more electronegative will pull the shear pair of electrons and it will leave the compound. That's why we call it leaving group. Secondly, this is alpha carbon and this is beta carbon. We know that this nucleophile OH of the base will attack on this beta hydrogen. So this beta carbon will lose one hydrogen. We get H2O. Now the electron of this beta carbon shift towards alpha carbon. We get this unsaturated compound. Thus we take tertiary alkyl halide. We add weak base like methanol to it and we convert it to saturated compound. Now what about the mechanism of E1 elimination reaction? Well, we have already learned that in the first step, carbocation is formed. As usual, we take third-degree alkyl halide. This halogen being electronegative takes its electrons and leaves the alpha carbon. That's why we call it leaving group. As a result, we get this 3-degree carbocation or tertiary carbocation plus this halogen ion. Remember that it is a slow step. Also note down this very important point which many talented people do not explain. This OH nucleophile is provided by the weak base methanol in order to pull hydrogen from the beta carbon. Now I take this 3-degree carbocation and place it here. We know that this is alpha carbon and this is beta carbon. This nucleophile will attack on hydrogen of beta carbon or beta hydrogen. As a result, water is produced. This carbon has lost one hydrogen and its electron will shift towards the alpha carbon. We get this unsaturated alkene. Remember that it is a fast step. Thus this is the complete mechanism of E1 elimination reaction. Now we will learn some important points about E1 elimination reaction. Remember that the molecularity of E1 elimination reaction is 1 because only one molecule takes part in the slow step. That's why we call it E1 elimination reaction. Secondly, there are 2 steps in E1 elimination reaction. Thirdly, the nature of solvent is polar solvent like water, methanol and ethanol, etc. Fourthly, the nature of alkyl halide is tertiary alkyl halide. Fifthly, what about the order of reaction? Well, we know that slow steps determine the rate of a reaction. We know that in E1 elimination reaction, the first step is a slow step in which only alkyl halide take part. Hence we write rate of a reaction is equal to K into the concentration of alkyl halide because only alkyl halide is present in slow step. Hence the order of reaction is 1. It means that rate of E1 reaction only increases if we increase the concentration of the alkyl halide. Remember that the concentration of polar solvent like weak base doesn't increase or decrease the rate of a reaction. Sixthly, E1 elimination reactions are fast in 3-degree carbocation, then in 2-degree carbocation, and they are very difficult in 1-degree carbocations. It is because 3-degree carbocation is more stable and 1-degree carbocation is least stable. Now I will teach you the most important question about E1 elimination reaction and SN1 substitution reaction. SN1 reaction and E1 reaction have the same mechanism. Then which reaction will occur? Well, it is true that SN1 reaction and E1 reaction occur simultaneously, but it is all about the temperature which decides the final game. Remember that at high temperature like above 50 degrees centigrade, E1 elimination reactions favor and major products of E1 reactions are formed, while minor products of SN1 reactions are formed. On the other hand, at low temperature like below 25 degrees centigrade, SN1 reactions favor and major products of SN1 reactions are formed, while minor product of E1 reactions are formed. Thus remember that both reactions occur at one time, but at high temperature, E1 reaction is more prominent, while at low temperature, SN1 reaction is more prominent. Hence note down this very important question. Now consider these 2 reactions. Can you differentiate between them? Well, this reaction is E1 reaction because of high temperature like 70 degrees centigrade. We can see that this carbon is alpha carbon, this is beta carbon. Also you can consider this carbon as beta carbon. We know the easy trick. In E1 elimination reaction, we remove halogen from the alpha carbon and hydrogen from the beta carbon. I remove this bromine from the alpha carbon and one hydrogen from the beta carbon, I get this alkene like propene. Secondly, this is SN1 reaction. Because of low temperature, we know the easy trick. In SN1 substitution reaction, we remove the halogen from the alpha carbon and attach a nucleophile on alpha carbon. We can see that this is alpha carbon. We will remove this bromine from the alpha carbon. Secondly, this CH3O is the nucleophile of the base. We will attach it to the alpha carbon. We get CH3C. This OCH3 is attached. CH3. Hence, using these two tricks, we can solve any question of E1 and SN1 reaction. For example, consider this another question. Pause the video and try to solve it. Well, we can see that this is E1 reaction and this is SN1 reaction. According to the trick, in E1 elimination reaction, we remove the halogen from the alpha carbon. Secondly, we remove the beta hydrogen and add double bond. Hence we get cyclohexene. In SN1 substitution reaction, according to the trick, we remove halogen from the alpha carbon and we add nucleophile of base to the alpha carbon. We remove this bromine from the alpha carbon. This CH3O is the nucleophile. We add this nucleophile to alpha carbon. Therefore, using this trick, we can solve any question of E1 and SN1 reaction. Hence note it down. Now I will teach you E2 elimination reaction and its mechanism. In E2 elimination reaction, we take primary alkyl halides and strong base like alcoholic potassium hydroxide. Here is one important question. Why we take strong base in E2 elimination reaction? Well, it is because strong base has the capacity to pull beta hydrogen in one step. For example, consider this reaction. I take primary alkyl halide. I add strong base like alcoholic potassium hydroxide to it. This is alpha carbon and this is beta carbon. Now this electropositive potassium will attack on this electronegative halogen. We get Kx. Secondly, this nucleophile OH of the base will attack on this beta hydrogen. We get H2O. The electrons of beta carbon will shift towards alpha carbon. We get alkene like propene. Now what about its mechanism? Well, I always write nucleophile OH is provided by the strong base potassium hydroxide. So I write here the nucleophile OH. Now I take this primary alkyl halide and I place it here. This is alpha carbon and this is beta carbon. We know that this halogen, being highly electronegative, will pull the electrons and will leave the compound. That's why we call it leaving group. At the same time, this nucleophile will attack on this beta hydrogen. The electrons of beta carbon will shift towards alpha carbon. Now listen carefully. I write the skeleton of this compound. CH3 single bond CH single bond CH2. We know that this halogen is leaving the compound. I show it by dotted line. Secondly, this nucleophile is attacking on this beta hydrogen. I show it by dotted line. Thirdly, the bond shift towards alpha carbon. I show it by dotted line. This stage is known as transition stage or intermediate stage. It is a slow step. Finally, this OH and hydrogen react to form water. This X leave the compound and we get alkene like propene. Hence this is the complete mechanism of E2 reaction. Remember that E2 elimination reactions are one-step reactions. Hence note it down these important points. Now we will learn some important points about E2 elimination reaction. The molecularity of E2 reaction is 2 because two reactants, nucleophile of the base and primary alkyl halide take part in the slow step. Secondly, E2 reaction is one-step reaction in which leaving group like halogen and beta hydrogen leave the compound simultaneously. Thirdly, the nature of solvent is polar aprotic solvent. Fourthly, nature of alkyl halide is primary alkyl halide. Fifthly, what about the order of reaction? Well, we know that slow step determines the rate of a reaction. We have already studied that in slow step there are two reactants, alkyl halide and base. So I write rate is equal to K into concentration of alkyl halide into concentration of base. Hence the order of this reaction is 2. Sixthly, E2 elimination reactions are fast in 3-degree alkyl halide, then in 2-degree alkyl halide, then in 1-degree alkyl halide. Hence noted down all these important points. I hope that you have learned all about E1, E2 elimination reactions.